Okay, wonderful. And it looks like we have our normal crew here. Cherry, Derek. Oh, Jatsna, nice. Wonderful. Welcome, welcome. Okay, so everybody, tonight's lecture is going to be on percents and their equivalent forms. So first of all, we have a pie chart. So hopefully you realize if you do add up all these percentages, a pie chart is just a way of indicating percentages because all of the percentages added up are 100. And you'll see why 100 is such an important number when it comes to percentages. So essentially, you can just think of percents as fractions that have a denominator of 100. So it makes it easy. So we've done fractions and we've done decimals. And so we know what denominators are. So percentages and fractions, we just know that we have a denominator that is 100. So for instance, if you have, and I just go through these quickly to kind of get warmed up, get everybody on the same page. So if we want to rewrite these as fractions, 33% is equivalent to 33 over 100. 6% is equivalent of 6 over 100. And lastly, 160% is 160 over 100. Now, I am not at this time going to simplify these. I'm going to leave them as is. The simplification of these are going to come later on. But just so you know that I do realize that yes, 6 100ths can be simplified to 3/50ths. And you can also simplify 160 to 16/10ths and further down into 8/5ths. And of course, you can always convert that into a mixed number of 1 and 3/5. Just a little practice working our way through from today's subject all the way through to what we did a few days ago with mixed numbers. Okay, so I will not convert those other samples. If anyone doesn't understand this concept, let me know now. I'd be happy to work some more examples for you. But okay. So of course, like we said, here's an example. 120% is the same as 120 over 100, just like we were just doing with our other examples. And they went further and simplified 120 down to 12/10ths, and then simplified it to 1 2/10ths, and then further simplified that to 1 1/5. So 120% is equivalent to the mixed number 1 1/5. Those are all different ways of saying the same thing, and you just need to be able to convert between all of those ways of expressing that number so you can use it depending on what the situation requires when you're out in practice, working with animals or people, as the case may be. So if you want to represent 120% as a decimal, like I said as I was going through the PowerPoints really quickly, what you will want to do, there is a decimal point right there. Your decimal point will need to go 2 places to the left, and then you will remove the percentage sign. So that is equivalent to 1.2. Move the decimal 2 places to the left, and then you remove the percentage. So 120% is equivalent to 1.2. So, which is pretty straightforward, but sometimes people can get a little twisted up when you actually have a decimal point in a fraction. It can be a little confusing to some people's eyes. So once again, decimal point goes 2 places to the left, and gives us 0.352, and then of course the decimal or the percentage sign comes off. And a tip I'll go out there, so for when you're in practice, you're charting and stuff, when you're writing numbers that begin with a decimal point, go ahead and include that 0 in front of that decimal point, because it cuts down on the error rate. It is a lot harder to make the mistake of not realizing there's a decimal point there if there's a 0 out front to kind of clue you in that it is a decimal and not a whole number. And the big difference between 0.352 and 352. Okay, and here's another example that can be a little tricky. 0.5% is equivalent. Now let's go through this. So 0.05. 0.005. Oh, I forgot a 0 place right there. So it goes 2 places up, 1, 2 to the left, 0.005. So 0.5% is the same as 0.005. So don't give away easy points. It can just be a little bit confusing when you have that, when you're starting with a decimal as a percentage. So if you can write percentages as decimals, of course you can write. Let's practice a little more. So 37% is the same as 0.37. 120% is the same as 1.2. And let's just do one of these. 0.8% is the same as 0.08. And I did the exact same thing. 0.008 did the same thing. So just be careful about those types of conversions. So as you may well have figured out, if we're going to change percentages to decimals, we're going to do the exact opposite, 180 degrees, and move percents or decimals to percents by moving decimal point 2 places to the right. There we go. 1, 2, same as 42%. So the decimal goes 2 places to the right while you're converting from decimals to percentages. I'm going to go through these, and these are usually a lot more easy, a lot fewer mistakes on these. 0.27 is the same as 27%. 0.09 is, of course, 9%. 0.5 is this, 2 to the right, 50%. And 4.89 would be 489%. Okay. Is everyone following along with everything so far? Okay, good. So let's take a quick peek at those. If any of those don't look like something you can do fairly easily in your mind, let me know. This, like I say, for the most part, once people know which direction the percentage or the decimal point is going to go, it is pretty downhill as far as given the correct percentages or decimal conversion. Oops. I won't work through those because if you got it, you got it. So the next thing we're going to take a look at is changing percentages to a fraction. So for instance, we have 4.5%. Okay, so as a fraction, we know we have a number that has a denominator of 0. So let's write 4.5 over 100. Okay, so that's a little awkward to work with because you're combining decimals with a whole number. So let's change that 4.5 to a whole number by moving that decimal place one place to the right. And we'll get 45. But of course, once you move the decimal place one to the right on 4.5, you also need to move the decimal place one to the right for the 100. So this now becomes 1,000. So 4.5 over the 100 is the same as 45 over 1,000. And let's just make sure we're staying in the habit of simplifying things. 45 divided by, let's start with 5. That'll be 9, and 1,000 divided by 5, 200. So 4.5% is the same as the fraction 9 over 200. Okay, so just to double check, let's run through this whole thought process. So let's divide 9 by 200. We get the decimal 0.05. That's the decimal. And if we want to convert that to a fraction, move the decimal 1, 2 to the right, and we end up with 4.5%. Okay? See how all of these concepts are starting to link together now. Start having a little fun being able to play with these different conversions. So let's do another one. How about 32.5%? We're going to change that into a fraction. So the first thing I'll do is I'm going to convert this 1/2 to a decimal. And I could get out the calculator and divide it, but I know that that is 0.5. So we have 32.5 over 100. And just like we did in the previous problem, we'll convert that to 325 over 1,000 and then simplify. Let's take 325, divide that by 25. That'll give me 13 over divided by, got a little carried away. (13/40), and then we can go about converting this 13/40 to whatever is the most useful way of looking at that fraction. So yeah, these other ones are pretty straightforward. And 34.2, of course, that is exactly just like the ones that we just did. You want to convert the 34.2 into a whole number and convert the 100 into 1,000, simplify, and you'll end up in the exact right place that you need to be. Next thing we're going to take a look at as regards to percents and decimals is changing a fraction to a percent. So we have 7/10. So the first thing we need to do is divide 7 by 10 to get a decimal, 0.7. And if we're taking into account what we just learned about moving decimal places to get percentages, move it 2 to the right, we'll get the number 70, and we'll tack on a percentage sign. So 7/10 is the same as 0.7, which is the same as 70%. So let's change something that looks a little more unfamiliar. We're going to change 2.5 to a percent. So we have a mixed number. We want to convert that into an improper fraction. So 2 times 2 is 4, plus 1 is 5 seconds. So 5 divided by 2 gives us 2.5. Decimal place goes 2 places to the right. That gives us 250%. Okay. Or the other way you could, of course, approach this is just convert the 1/2 into a decimal equivalent. So we know that that is indeed 0.5. So we 2.5, skip that step and go straight to 250% as an equivalency to the mixed number 2.5. Okay. Would you guys like me to work any of these problems converting 1/5, 4/5, and or 7/50 into a fraction? Not too bad, right? Okay, so I mean, don't, slow me down. If you don't really see what I'm doing, please stop me and have me work some more problems. I would much prefer that you have these firmly in hand rather than when you're doing your homework or the quiz. So let's use all of this knowledge to start solving some problems, such as you might see out in the world and out in practice. So what is 15% of 63? And you would start that by converting a percent into a decimal. So 15% is the same as 0.15, moving that decimal to the left and taking away that percentage. We want to multiply that by the number we're looking at, which is 63. So that would be 0.15 times 63. So the number 9.45 is 15% of 63. So another way we can look at these numbers is if we want to find out what percent a number is of another number, set up the fraction and then perform the math to arrive at your decimal. So we know that the denominator is 42. That is the full number we're looking at. And we want to know how much of 42 is 21. And that's just a simple matter of converting that into a percentage, excuse me, a decimal, 0.5, and then converting that decimal into, oops, that's huge. Converting that decimal into a percentage, which would be, of course, 50%. So 21 is 50% of 42. And then all the various permutations on how to manipulate decimals and percentages. If you're given one number, what percentage is it of another number? A number is what percentage of another whole number? All of those types of problems are easily solvable if you just know which direction you need to go with your conversions. So let's combine the concept that we're working on tonight, which is percentages, and with what we looked at last night, which was proportions, and do some problems here. So we just did what is 15% of 63. We've actually already worked that problem. And we've also worked this problem. What percent of 42 is 21? So you might come across a problem like this. When you are given a 60 milliliter bottle of medication, or no, excuse me, hydrochloric acid, that has 80% of hydrochloric acid. Okay, so they want to know how much hydrochloric acid is in that, and we are setting this up exactly the same way like we did just above. So we have a 60 milliliter bottle. We'll convert that percentage into a decimal by moving it 2 to the left, and then simply performing our calculation times 0.8. So of that 60 milliliters, 48 milliliters is hydrochloric acid, and 12 milliliters is something else. Probably water, but it doesn't really tell us. Let's look at another example here. So we have a topical pain reliever that has 52 grams of total solution. If the label says there is 5% lidocaine, how many grams of lidocaine are in the bottle? Okay. So once again, we have 52 total grams times 0.05. Once we convert that percentage into the decimal, perform our calculations. 52 times 0.05 is going to leave us with exactly 2.6 grams of lidocaine in that topical ointment. So you probably can't read that, but let me just read that one out to you. So we have, if 48% of the students at a college are female, and there are 2,400 female students, how many students are there total at the college? Okay, so we have a proportion here. So let's set up this proportion and solve for unknown. Okay. So we have 48%. The fraction is 48 out of 100. So we know that a fraction is a fraction with a denominator of 100, and we know that the total number of females is 2,400, and that is going to give us an unknown of the of x. So cross multiply. Okay. So x is equivalent to 1,000. You know what? I did not set that up correctly, guys. I apologize. So it's 48% at the total student population is female. That means subtracting 48% from 100 leaves us. So we know that 52% is male. Okay, and that leaves us with X being the total number of students. And now we have an equivalency that we can set up and get the correct amount. So we have 48% is to 2,400 female students. Okay, as 100% is to X, which would be the total number of students. And then we can solve the equivalency. So another usage for percentages is if we want to find out the sale item, and this is like the last few problems on your homework. If a cell phone retails for $149, ooh, I got ugly in a hurry. $149.99 is the total cost, and it is 25% off. You want to multiply 149.99 times 0.25, just like we said before. And we get the 25% discount is 37, we'll just call that round up to 50. So that is the amount of the discount. So to arrive at the net price, we need to subtract $37.50 from our initial price minus 37.5. So total price is $112.49 is the net price. Round up. So $112.49 is the price of the cell phone. Okay. On the other, sometimes you do not need the net price. For instance, if you are calculating a tip, a 25% tip on a bill of $167.34. Once again, I'm going to convert 25% into 0.25. Multiply that by 167.34 to arrive at an approximate tip. So approximately $41.84, or actually, yeah, rounded up to the nearest penny. However, another way, since you always know that the denominator is 0, that allows you to manipulate things in your head a little more without using a calculator. And so if you wanted to calculate this or get close to this number and impress your friends and family when you're out to dinner, you could do something like breaking 25% down to 10% plus 10% plus 5%. Okay? And you can do this all in your head. So let's round 167 up to $170, just to make the math a little easier. Multiply 170 times 0.1 or 10%, that's $17. Multiply 10% times 117 or 170 and get $17. And then half or 5% of 17 is going to be approximately, well, it's $8.50. You can just go ahead and round that up to $9. And then add 34 plus 9 gives you about 33. So, 34, excuse me, 43. 34 plus 9 is 42. So approximately $42 is what you'd come up with. Doing the math in your head by breaking it 25% down into 10, 10, and 5, and just multiplying it by the original bill. And there they just walk you through that process as well. Okay, so you should be able to write each percent as a fraction, then as a decimal. I'll do the first one. So 25% as a fraction is the same as 25 over 100. In simplest term, that's 25 goes in itself once and 100 4 times. So that is the fraction. Then as a decimal, whoops, 1 divided by 4, 0.25. Okay? So I won't do the rest of them unless that didn't make sense to you. I'll be more than happy to circle back and work anything that you want me to return to after lecture. Okay, there's 1/4, 0.25. When you're going through those slides, if those numbers don't make sense or you don't understand, yeah, let's do 383. That could be a little tricky. So as a fraction, that is 383 over 100. Of course, you can convert that into a mixed number, which would be 300 minus that would be 83 over 100. So that is simplified. And then divide 83 by 100 to get your decimal. That's 0.83. You keep that whole number out front. A little bit tricky on that one. Okay. So let us look at converting each of these percents to fractions and decimals. So 66 and 2/3%. So let's write this as a fraction. So let's first turn it into a decimal. We'll go 66 and 2 divided by 3. Go 0.66. We'll just say 0.66. 66.66%. And then, of course, move your decimal point 2 places to the right. Get 600. That's right, 6.66% as 6.66 over 100. Move that decimal to the right. Over 100, and then 10,000, and then simplify that fraction. Okay. Okay. And the last thing, I think it's the last thing, maybe I have one more thing. You want to write each fraction as a percent. So the first thing you want to do, for instance, you have 27/50ths. Oh, pardon me. 27 divided by 50 is going to leave you with 0.54. And so you have a percentage or a decimal. To turn that into a fraction, you want to move that decimal 2 places to the right and get 54%. Okay, 1/3, same as 33 1/3 and 48%. And I was wrong. So we want, last thing we'll do is convert each decimal to a percentage, which you actually just did in the two-step process and converting a fraction into a percent. They give you the percent ahead of time. Move that 2 to the right, and you'll end up with 16%. Let's see, 0.006. That type of number can be a problem for people sometime. Move the decimal 1, 2 to the right. That is the same as 0.6%. And that is it in a nutshell. I know I was a little faster this morning, but this tends to be one of those lectures that if you followed everything up to this point, it doesn't present that much of an issue. That being said, does anyone have any questions and want me to go back and take a look at anything in specifically? All seem pretty good? Okay, good for Derek. Jats, you good? Okay. And Charity, can't see you, but speak up if there's something that was challenging to you.
I'm good, thank you.
Okay, guys. All right, yeah, I mean that's pretty typical on decimals and percentages. Okay, sounds good. Okay, so that is it. You are free to go.